Hi, this is Mr. Sapone here, and today we're going to take a brief look at graphing, or how to create a graph. And there's a awesome little acronym or mnemonic we use to remember some things we need called TAILS. Whenever you're creating a graph, you should think of the word TAILS. And of course, every graph needs a title, you need labels, units, scale. Please fill the page. If you have this is a graph sheet of paper, don't create a little tiny graph like this. And we'll kind of go through these. We want our interval equally spaced. Know what you're putting on your x and your y-axis in terms of dependent versus independent variable. One thing I will say is if you're creating graphs, always put time on the x-axis. So let's just take a look at some of these things and we'll see what they mean step by step. So if we have some data over here, let's suppose this is the distance a car or any object traveled, and these are time values telling us how long it took it to go those distances. Of course, tails, the first thing we know, we need a title and labels. And we can put those in. The y-axis is, of course, distance. It's measured in meters. Put the unit as well. Distance doesn't help if we don't know the unit. And, of course, we have time down here measured in seconds. So we have these things. And the next thing, what I mean by fill the page, is relatively simple. If you have a graph this big, don't plot your points so that way you only end up with a line that fills a third or a quarter of the paper. You want your graph to look nice. You want it to be big so whoever's reading it can see your data. You want it to fill the page. You need to come up with an appropriate scale, a number system on the XY axis, so that way your graph takes up the entire sheet of graph paper. And another thing students often do is when you're plotting data, if we look over here and we look at these numbers, they are identical. We have 0, 0. We have 2, 2, 4, 4, 6, 6, 9, 9, 14, 14, 18, 18. What the student did, or what sometimes happens, they take all these numbers and they simply plotted them over here. And this ends up with us always having a straight line, and this line shouldn't be straight. You do not want to do this with your data. In this case, time is okay, 1 through 10, because time is moving in equal divisions. But for the most part, each box or each interval should have the same value. And what I mean by this is we need to make equally spaced divisions. Very, very important. Equally spaced divisions. This is our interval aspect. Each box represents 3 units or 3 meters. From 3 to 6 is 3 meters. From 6 to 9 is 3. From 9 to 12 is 3. 12 to 15 and so on. It's an independent scale. Each box must be the same amount as the box before and the box after. And our time is fine because each box is worth 1. The difference is 1. You always want equally spaced divisions. Do not take this data and put these points over here because you end up with a straight line, and we are not supposed to get a straight line. And let's actually plot this data and figure out, make sure we know how to do it. So if we wanted to actually plot this data, we're simply gonna take our points and match them up. Distance is 0, time is 0. Well, my distance value is 0 here, time is 0. So the first point is at 0, 0. Our second point has a distance of 2, which is about right here. It's in between the 0 and 3, but closer to the 3. And at t, or time, equals 1. So at 1 second, we have a distance of about 2, which that's 2, that's 1. It's where these two lines intersect. At a distance of 4, or at a time of 2 seconds, we are at a distance of about 4, right here. At a distance, when we're at a distance of 6, right here, the time is, of course, 3 seconds. So we go over to where 6 and 3 intersect. 3 is going up, 6 is coming over. They intersect right there. That's another point. And, of course, we have 9 and 4, where 9 and 4 intersect. The next point is 14, which is pretty close to the 15 value, and 5. And of course 18 and 6 right there. 6 is right here on this line, 18 is on the line. 22 and 7, 22 is going to be closer to the 21. We're going to go right there. And finally 24 and 8. And you see, notice how I pretty much filled the graph paper. My graph goes high. And notice I didn't plot these values here. If I put these values here, I get a straight line, but this isn't actually a straight line. This line kind of goes like this, and then it curves up a little bit, and then it kicks back. So this line, this is actually wrong. This should go like that. But this line has a little curve in it. It's not a straight line. The speed actually is increasing here. It has a steeper slope. So when you plot these data points as your x value or your y value intervals, it kind of skews your graph. You don't get the results you want. So always create an independent scale and make them equally spaced the divisions. And so again, that's how we graph. Remember tails, fill the paper, equally spaced divisions. This is Mr. Spohn. Hopefully that helps you graph.